Hello. Hello, am I audible? Hello, am I audible? So let's start with question 1. Calculate the molar mass of Na2CO3 dot 10H2O. Calculate the molar mass of Na2CO3 dot 10H2O. Need to reply. Anyone getting the answer? One 142. 142. Anyone else? Call 286. All right. Let's solve it. 2Na plus C plus 3O. And here 10 into H2O. So 2 into 23 plus 16. Sorry, 12 plus 3 into 16 plus 10 into 18. So 46 plus 12 plus 48 plus 180. So this total will be 106 and this is 180. So 286 is the right answer. 286 will be the right answer. Let's see the question 2. Calculate the number of moles and molecules in 220 gram CO2. In 220 gram CO2. Calculate the number of moles and molecules in 220 gram CO2. Try to find out. 5 mole. Calculate the number of molecules. Anyone else? 5 moles from 5 moles. Okay, moles is equal to mass upon molecular mass. So mass is 220, molecular mass of CO2 is 44. So here 5 mole is the right answer. So number of molecules is equal to moles into Avogadro number 6.02 10 power 23. So it is 30.1 into 10 power 23. So it is 3 into 10 power 24. 3 into 10 power 24. I hope it is clear. Okay, let's solve the next question. Question 3. Calculate the mass of Fe produced when 160 gram of Fe2O3 completely react with excess CO, that is carbon monoxide. As per the reaction is given Fe2O3 plus 3CO gives 2Fe plus 3CO2. Atomic mass are given Fe, that is 56U, oxygen, that is 16U, carbon is given 12U, and options are given: A 56 gram, B 112 gram, option C 160 gram, and option D 224 gram. Try to solve this. Okay, how many of you are present? Write your name in the chat box and just write present. And we can have interacting sessions. Okay, Kalp is present, Harmish is present. Okay, me is present. You can ask your friends to join, I don't mind. Hi Maulik. You can tell others if they can get a JEE revision. Question 4. Okay, answer for this will be 112 gram, as Armish said. Weight of Fe2O3, if you find the molecular weight of Fe2O3, it is 160 gram per mole. And here the weight is 160 gram. So if you burn 1 mole of this, you will get 2 mole of Fe. And 2 mole of Fe means 112 gram. 112 will be the right answer. Calculate molarity. Sorry, molality it is. When 10 gram of NaOH dissolved in 500 gram pure water. Option A 0.25 molal, option B 0.5 molal, option C is given 1 molal, and option D is given 2 molal. So 160 and actual mass is also 160. So 1 mole of Fe is heated over here, 1 mole. So it gives 2 mole of Fe. 1 mole of Fe2O3 is heated with CO, but it gives 2 mole of Fe. So 2 mole of Fe means it is 112 because mass of Fe is 56. So 56 to the 112. So it is clear. Now solve this molality. Option B 0.5. Tell me about the molality. Molality. B is the right answer. 0.5 molal. Molality means mass upon molecular mass in weight of solvent in kg. 0.5. So when you solve this, you will get 0.5 molal. Perfect. Question number 5. Calculate the formal charge on central oxygen in ozone molecule in Lewis dot structure. -1, 0, +1, and +2. So to draw the ozone molecule, anyone? Okay, +1. You are saying +1. Ozone molecule looks like this, and here lone pair are there. Okay. So for formal charge, valence electron minus lone pair upon bond pair by 2. So valence electron are 6, lone pair electrons are 2, bond pair are 6 by 2, so that is 3. So +1 will be the net charge. Very good, Kalp. Perfect logic. Okay, let's see the next one. This I need to erase. Calculate the wavelength. Calculate wavelength when electron in hydrogen atom goes from 2 to 1. Energy level 2 to 1. Options are given: 1.2 nanometer. Option B is given 1 to 1.5 nanometer. Option C is given 486.1 nanometer. And option D is given 656.3 nanometer. Let's see. Okay, option A. Let's see. Anyone else? (91.2 nanometer confirmed. Okay, let's solve. You can use this shortcut formula 91.2 n2 square into n1 square upon n2 square minus n1 square. You can use this shortcut formula. So it will be 91.2 in bracket n2 square is, you can say, 1 square, or you can just write 2 square minus 1 square upon, sorry, into 2 square minus 1 square. 91.2 2 square, that is 4, into 1 square upon 4 minus 1, that is 3. This is in nanometer. So here you have to write nanometer, here you have to write nanometer. So when you solve this out, it is 30 and it is 120. So 121.5 nanometer will be the right answer. Option B will be the right answer. Any doubt? Okay, all are there. How many of you are there? You can write present. Everyone are there. Is there any doubt? You can ask. You can also write this shortcut as well. Okay, let me give you one more question. I'm keeping the formula so that you can use it. Find the wavelength for transition from n equal to 5 to 2. Okay, for this transition, and one question for this transition. Transition for 4 to 3. These two transitions you need to calculate using this formula and tell me the answer. 5 to 2 and 4 to 3. You can just directly write the answer in chat box. $434. 480. 480. First one, second one. 1479 in the second answer. 1479. 1479 is incorrect. Okay, shall I give the answers? Shall I give the answers? Here the answer is 434 nanometer, and for the second it is 1876. 1876 nanometer for the second one. 1876 nanometer. I hope you can solve it. Okay, let's solve the next question. Organic compound has empirical formula. Organic compound has empirical formula of CH2 and molar mass of 56 gram per mole. Determine the molecular formula. Option A is CH2, C2H4, C3H6, and D is C4H8. What could be the answer? What could be the answers? Option D. Okay. Option D. It is simple question. First you find the value of N. So it is molar mass, that is 56, and mass of this empirical formula is 12 plus 2, that is 14. So here value of N will be 4. So molecular formula will be 4 into CH2. So it will be C4H8. So option D is right answer. Question: calculate wavelength of a 100-gram ball. 100-gram ball moving with speed of 6.63 meter per second. 6.63 meter per second. Calculate the wavelength of 100-gram ball moving with speed of 6.63 meter per second. One into 10 power minus 32. Okay, let's solve it. Lambda is equal to H upon mv, 6.63 into 10 power minus 34. Mass is 100 gram, so it is 10 power minus 1 if we consider it in kg, and here velocity is 6.63, so you can directly cancel it out. So 10 power minus 34 plus 1, it is 10 power minus 33 meter. So I hope it is clear. 10 raised to minus 33. Let's see the next question. calculate the energy an electron in H atom transit from 3 to 2 in electron volt. You need to find it in electron volt. Three to 2. In terms of electron volt, you need to calculate. I guess you know the formula. In terms of electron volt, find out. Anyone else getting the answer? Three to 2 you need to. Okay, let me tell you the formula then. It is 13.6 because we need to find it in electron volt, NF upon Ni square. Now I hope you can calculate it. Now I hope you can calculate this. Still not getting? You just need to put the values. 13.6. Your final is 2. So 1 upon 4 minus 1 upon 9. So it will be 13.6 into 5 by 36. Okay. Whatever the answer you will get, that you need to put. It will be around 1 point something. Exact answer is 1.89. 1.89 electron volt. Any doubt? Anyone? Let's solve the next question. Wavelength is given, let's say 410 nanometer. Find the energy. Wavelength is 410 nanometer. You need to find the energy. Okay, try to find the energy. Wavelength is 410 nanometer. Try to find the energy. What is the formula? I guess you're gonna use this is equal to hc by lambda. hc by lambda. This you will use. hc by lambda. You can solve. 4.8 10 power minus 19 joule. Okay. Four point eight 10 power minus 19 joule. Okay, that is perfect. 4.8 10 power minus 19. That is a perfect answer. Now see, there is one more trick. Okay, before that, if you want to find it in electron volt, then what will be your answer in electron volt? That you need to tell me. Electron volt. Then what will be the answer? What will be the answer in electron volt? 3 eV. 3 eV. Divided with 1.6 into 10 power minus 19. That is the way you can convert it from joule to electron volt. So 3 eV is the right response. Now see, energy is 1240 upon lambda in nanometer. If you use this equation, you will directly get the answer in terms of EV. Again, this is a very important trick. 1240 by lambda, this value is 410. So 1240 divided by 410. So it is almost, you can say, 3 times. So answer is 3 eV. If options are given in terms of electron volt, you can directly use this formula and just tick mark the correct response. Is there any doubt? Okay, so using the previous trick and this trick, let me give you one more question. Okay, let's probably we'll keep this as a final question for the day. Find wavelength in nanometer and energy in electron volt, and let's keep the transition 4 to 1. Electron transit from fourth orbit to first orbit. 4 to 1. Try to solve this. Let's see. You have both the formula, previous one and this one. Using that, you can quickly solve it. For 4 to 1. Try to solve it. "97 nanometer, that is the right answer. For wavelength, you can use 91.2 n2 square n1 square upon n2 square minus n1 square. You will directly get the answer in terms of nanometer. "13 eV, approx 13 eV, that is also a correct one. Just put the values, you can solve. So 91.2 n2 square, that is 1 square into 4 square, here 1 2, so it is 4 square minus 1 square. No need to take it negative. So 16 upon 15. So this is approx 97 you might be getting. Exact answer is 97.3 nanometer. And from this, if you put the value of this 97.3 over here and divide it, you will get the value 12.75 eV. 12.75 eV. So is there any doubt you can ask? So I hope it was very fruitful session. You have solved many numericals from different concepts, right? But when you divide it 97, 1240 divided by 97, how you get 3?